Okay, so just as an aside, this as I drove in this morning, I noticed this sign. This is just a comment, got nothing to do with my presentation at all. But does anybody know what that means in England?
Yeah.
No.
More like this, right?
Yeah, it's more like the one finger salute in America. So I was like, are they welcoming me or what is this?
Just for you, they did that.
It just cracked me up. I don't know. But anyway, so what I was gonna.
Well, welcome.
Yeah, thank you. I appreciate it. If they just turn it around like this. So what I was going to talk about this morning is just, I'm going to focus on my little niche of the market, which is the structural steel industry. My name is Chris Moore. I'm the Director of Industry Initiatives. I'm also the Chair of the National BIM Standard. In my role, I look at technology from other industries. I look at technology in the industry. I look at the steel industry and I see what technology they're using, and we try to find better ways to use that technology, better ways to communicate between various parties in the supply chain, and just always looking for a better way to innovate and push forward the industry for more efficiency. So what I wanted to talk about this morning was just about the steel industry, some of the technology we use, some of the technology that's coming online, some of the technology that's just behind that in the second wave coming online. So I'm going to show you a few videos. And then I'm going to talk about a little bit of a vision project we've got going on and what that showed us in terms of technology and how, where the gaps are, where we might need to fill in some of the gaps and where some of that technology might be able to come into the industry. Now, I don't necessarily have any answers for that last bit. This is my first time to AEC Hackathon. I was kind of curious about what it's all about. I've kind of got it now. I've been here for 2 hours and I've got it. So really, a lot of the back end of this presentation will really be about just questions. There's stuff going on in the world here. How can it apply to the industry here? And you know, maybe through this and through other conversations, maybe there are some synergies that we can tie together. So just a very simplistic view of the steel industry. And this is really 3 areas that we focus on. We've got the fabrication industry itself, so the processes in here, the installation, the detailing, the production of the 3D model, you know, the BIM. We've got that to worry about. We've got the communication with the AEC, communication with the architect, the engineer, the contractor, crossing a contractual boundary most of the time there, but we've got to be concerned with how that communication can be improved as well and what technology can improve that communication. And then we've got the purchasing of materials. So in order to fabricate anything, we need the material. So how do we better communicate between the material suppliers and the material producers and the industry itself? Now, as AISC, or as an industry, we're tackling all 3 of these areas. We're tackling problems in here, we're tackling processes here between these 2 groups, and we're tackling a process here by creating a new standard for let me just diverse. Most steel, 99% of this stuff here is purchased by fax or by emailed PDFs and such. Okay, it's 2014. God's sake. People are still using. I don't even have a fax. When was the last time anybody in here used a fax? Right, 99%, even closer to 100% of steel is purchased that way. So one of the things we're doing, just as by way of an example, is we've created a new open standard XML schema to support all of the transactions of steel. So it's the first step towards true e-commerce where people can actually self-procure their steel. Not rocket science, but this is how far the industry is behind, just to lay a foundation. So let's go through some of the things we know. And I don't know who knows this in the room and who doesn't. But some of the things we know is that the steel industry has been using 3D technology, 3D modeling, since probably around about 1989, 1990. Okay, I've been using it since 1992. Okay, 10 years later it got called BIM. Okay, fine. Well, I don't care what it's called. The fact is we've been using this technology to produce fully connected models that are capable of then producing all the information needed for fabrication. Okay. So we move forward and we get to things we know again. We've been using computer-controlled equipment for a long time. Equipment that can drill, that can saw, that can punch, coat, pre-processed beams. And it's driven from the model. So the model produces files that these machines can then take and, it's pretty interesting stuff as well. Here's a coping machine, just to give you an example. But it takes the files from the model, it reads the files, and it can automatically do all this work. So it can cut, it can cope, it can drill, etc. Okay? I'm not going to spend too long on the videos, but just to give you an idea, this is going to burn some holes, it's going to burn the end of the beam. The finish on the end here doesn't need grinding, it's perfectly, these are pretty advanced machines. The point here is, we already do this. This is already existing. I want to just show you this one because it's just some extra things.
This exists in this country?
Oh God, yeah. The steel industry's been using this around the world for probably 20 years. These kinds of machines. So here's this is actually a multiple machine. This is doing some scribing, so it's basically marking out where a piece fits later for the fitter to actually come in and say, okay, it fits on that thing. Bear in mind, it's read this from a file. Okay, the files are single process, single piece files, so it's an NC file, numerical control file. So it knows where all the holes are. This is a 3-axis, 3-spindle drill. It's drilling flanges at the same time as it's drilling the web. It knows exactly where those are. It's pretty damn quick as well, by the way. It can process that beam very fast. It makes it look like butter.
You can pick this up at Home Depot, right?
Yeah.
So this is pretty good technology, right? And we've been using this for years, long time in the industry. Speeds things up, and then it's doing some milling as well. So this isn't going through, and it also does some tapping as well, so it also taps if need be. But it gets all that information from the 3D model. You're looking gross, so I'm just going to leave it on.
Better than your log.
It just carries on doing the same thing. There's no finale, okay? There's no plot or anything like that. Okay?
And
The point here is, it's doing all that. We've got this fully connected model here. It's got all the information in it, and we've got to get that information to production planning, and we've got to get that information to the machinery, okay? When I show you that we've got a fully connected model, and I show you the machinery, it looks fantastic. But actually, when you dig a bit deeper, this is what's happening. There's all kinds of different files going across the way there, all kinds of different formats. And as more machines get more and more complex, which I'm going to show you, the machine manufacturers need to make proprietary formats to handle the data that the old NC files that have been in existence since the 1980s can't handle. So we have this problem that, and also, by the way, the various settings, different settings have to be known here at the detailing stage when they're creating the model to know the boundaries of where the drill is or how far the drill needs to be from a flange. And all these settings need to be different according to where the data ends up. So actually, this guy needs to know a lot about this and this in order for him to send the right files. I also mentioned that we talk about NC files here. On any given job, say a job of, let's say 3,000 ton, okay, or 3,000 pieces, let's say. Actually, rather than doing math, let's just pick 1,000 pieces, because then I can just multiply that one. NC files are single piece, single process files. That means that if a beam needs to be cut to length, it needs to be drilled, and it needs to be coped. That means 3 files. And those files don't have any version control in them. Okay? So now you've got 3,000 files, possibly, even more, NC files that need to be handled and managed by somebody somewhere. It's a mess. However, it works because people have got used to doing it, used to managing it, and used to having these servers, and so change is always difficult. We know that. But as I say here, it's a process that works, but it hasn't changed for about 20 years. And now we're coming into a time where we're getting to more advanced technology. advanced equipment, advanced machinery. So we've got, I already showed you a little bit about the automated layout. This is where the actual equipment will draw on for the fitter where the pieces need to fit, so where a clip angle needs to fit or where a plate needs to fit. And they draw that on, and it basically does away with drawings. I mean, I'm simplifying it a little bit, but the drawings don't need to exist because all the information's on the beam. It tells you the weld size, it tells you where pieces fit, it tells you the piece part, and it's all drawn directly onto the beam. Several methods: scribing, laser, and another one. I can't remember. Then we get to robotic welding. Robotic welding is, it's been big in other industries for a long time. It's not been big in our industry, but it's the next wave of big thing. Well, if you think about robotic welding, if something's going to weld two things together, it needs to know where they are in relationship to each other. So an NC file, single part, single process, single part, single process, has no relationship to where it goes. So the robot needs to be able to read context and read relationships between different pieces. So therefore, in order for this to work, we need a better way of managing that data, better way of reading the model data, creating the relationships inside of the equipment, and then putting the pieces together. And if you like that last video, you'll love this one. So this is automated assembly now. Now this is only going to work right now for sort of simple beams with clip angles or plates on. But what this is doing here, it's basically reading a model. And again, I'm simplifying the process, but it's reading a model. It's telling the operator which pieces it needs. Okay? The operator goes and collects the pieces, puts them on a conveyor. As they go through the conveyor, there's a scanner. You'll like this, Malcolm. There's a scanner, reads the pieces. Okay? It reads the pieces, recognizes them, says, okay, they're the right pieces, they're the right length, identifies which they are. And then, the scanner also scans the actual beam itself for distortions and what have you, and make sure that, if there's a bend, it can allow for that when it gets to assembly. I'm trying to talk slowly because this takes a while to catch up to me. But what this then does is it picks up the pieces, reads the model, places them in the right place, and welds them on. This is a pretty impressive piece of kit. There are only about 3 or 4 of these in the world in use today. But they are in use in other industries. But this is definitely one of the things that's coming towards us. And again, if we are going to have machines that can do this type of thing, we need file management that can handle the relationships between the various pieces. What's had to happen here is the equipment manufacturer has had to produce a proprietary file. Proprietary files are closed. If another equipment manufacturer has to create something similar, something competitive, they will create a proprietary file. And the fabricator's got 2 proprietary files to manage. And that is against everything we all here should believe in, because what we want is an open system so that you can choose the best machine to do the best job for you. So again, there's no particular plot to this story, to this video rather. It just carries on doing good things. Okay, so that's pretty advanced technology, right? That's in use today. And the next wave of technology is also in use. In fact, I could argue it's in use in more places. Because now what we're getting to is a situation where the machines in the shop are connected. So you've got the drill that's connected to the saw, that's connected to the coping machine, and they are also connected to the conveyors that move the pieces around. Okay? So what that means is that you, first of all, I'll actually show the video as I talk. Now this to me is really impressive. Because now what we've got is some raw material coming into a shop, and that raw material may be 60 foot long. Okay? That 60-foot piece needs to be cut into a 20-foot piece, a 15-foot piece, and a 25-foot piece. Is that up? Anyway. The first piece needs to be cut to length, and it needs to be drilled, and then it can go to assembly. Okay? Well, the conveyors take care of all that. It knows that B1 only needs to go to machine A and machine B, and then it can get off the conveyor system and go to the assembly bay. Beam 2 needs to be coped as well. So it needs to go to the saw, goes to the drill, goes to the coper, and then goes to assembly. No humans involved here. Okay? You just put the piece on, tell it which pieces you're doing, and off it goes. This is an animation of a real shop. This isn't made up or anything. This is an animation of a real shop. Okay? What this enables you to do, these machines are, first of all, what you get is a work supervisor who manages several machines. So he just makes sure they're going. He's not operating the machines. He's just putting the material on the front and making sure they don't stop. And what this means is that the machines know what they're doing. They know where they're sending the piece. But it also means that that data is available for real-time supervision. So I could be sat here owning a fabrication shop. I've got my tablet in front of me and I can watch what's going on in the shop. I'm sure my workers don't appreciate that, but this is real. This is in about 55 installations around the world. Okay, so this is actually working. Now then, that's pretty cool stuff. Take that to the next level, and what you get is this. Now you've got the ability, because your machines, you know how long it takes, because you've got all that data from when you've actually run things through it, and you've got the status data, and you can watch and supervise. So now you know how long things take. Now you can prefabricate everything before you've even purchased a piece of steel. And say, how long is this going to actually take me? Okay, you getting it? I mean, so now you can say, you can go to a bid, or you can sit in with your general contractor, or you can sit in and say, you know what, let's see how long this is going to take. And not only that, let's see where the bottlenecks are so that we can adjust the work pieces to different machines according to how I can increase my productivity. You can see the productivity curve going up here. This is actually false because there was no work in the shop when this started. That would never be the case. There's always work. It's just a case of where do you fit in the new work. But bear in mind, this guy might not have purchased a piece of steel yet. Imagine the power of that for a fabricator to go and sit with a GC or a general contractor or during a bid and say, let's see what we can do here. I mean, I'm really going to show you how we fabricate this before we purchase anything. This is really powerful stuff. And this, of course, enables, then afterwards you can actually monitor this and see where the problems are as well. So you can live monitor it and live shift things around according to what's really going on. So that's the end of my exciting videos. I'm sorry. I've talked a lot about a lot of file management. You remember that mess before. So one of the things we are doing is we've developed a IFC open format model view definition, and it's slowly going into the industry and slowly being implemented. The definition is done. Phase 1 was done last year. Phase 2 is done right now. And what this is going to do, it's going to eliminate all of that mess that you saw before. Because all we're going to do now is we're going to export all the information, all the geometrical information from that model into a single file. And then we are working with, you can see the names at the top there, we're not doing this in isolation, we're working with the software vendors, we're working with the equipment providers. So that what they'll do is they'll say, okay, well it doesn't matter who this detailing system is, it doesn't matter whether it's STS2, Tekla, Autodesk, it doesn't matter. What we've got is an IFC file. From that IFC file, the software vendors who do the production planning can just go and pull the data they need for scheduling and organization. Okay? The equipment manufacturers, bear in mind equipment is done without a software interface, so they just go and pull the information they need, turn it into the algorithms they need, and drive the machinery. Okay? It's a paradigm shift, and it's a paradigm shift in more than one way. First of all, you've only got one file. Second of all, it's an open file, it's an open standard. It makes everything easier to manage. Third of all, it removes guesswork, because this idea of file export means I'm guessing what you want. I don't know what you want. What this enables you to do is change that paradigm to file import. And basically it says, I'm going to go and get what I need. I'm not going to rely on you to give me what you think I need. Because most of the problems that occur are because people didn't give the right information in the first place. So we've done this, okay? This is this is done. We're in a mode of implementation and pushing people to adopt this now. Because just a commentary, but 50% of any new innovation is not the technology side. 50% of it or more is education and promotion. Okay, we can do the technology easily. Getting a conservative industry to adopt that technology is a whole different ballgame. So that's great. We've got a pretty interesting future in the industry, but it seems to me there are a lot of gaps. And there are gaps in what I've showed you in terms of the process, but I think there are also gaps in terms of thought. And I've only been here 3 hours this morning, and I've already come across things that show this presentation is out of date. There's gaps in technology that's being used in other industries or other arenas, or in the commercial area, or mobile phone era and all general applications that are not being thought about for our industry. And I'm not just talking about the structural steel industry, I'm talking about the industry as a whole. So one of the other things I do in my spare time is I chair this group called Division Task Force 2021. It sits under the National Institute of Building Sciences. And this group was tasked with looking forward into the future and establishing a pretty clear vision of what the construction industry will look like in 10 years. The reason why we chose 2021 is because it's reasonably predictable. Whatever the leading guys now are doing, you can pretty much say that's what the rest of the industry will be doing in the future. Okay? Everybody agree with that? 2%ers, the bulk of the industry is going to follow on, and the laggards will still be there in 2050, but that's a whole different story, right? So we got about 40 different experts from around the industry, ranging from real estate owners to insurance, to steel contractors, to structural engineers, to MEP, the whole lot, to write us a vision of what their job looks like in 10 years. Okay. And from it, you'll see the results in probably about 6 weeks. We've got a publication that we're putting together. These were the sponsors that helped us do this, helped us put all this together. So some pretty big hitting names there. I need to thank those. But from this, I just want to focus on some of the technology that came up. Okay. These were the general 6 areas that if you pull out all the data, you can sort of categorize it and put it in various spots. Those are the general 6 areas, but what I want to focus on today is this technology. And these words here are nothing you don't already know, nothing you don't already understand what those words mean. The cloud, whatever the cloud is, sensors, drones, safety tech, augmented reality, okay, robotics, wearable tech, Google Glass, that kind of thing, laser scanning. We talked a lot about laser scanning this morning with Malcolm. The dominance of mobile technology and being able to carry that technology with you, and the accessibility of data, sometimes called big data, right? Which I argue big data has always existed, by the way. It's just that it's always been in drawers on paper. It's the accessibility of that data. It's not the fact that the data was never there. It's accessible data. So I just want to walk through this. I don't have any answers here. I don't have any answers. I just want to, I've been in that room in there and I see a lot of energy and a lot of thought and a lot of things going on. I'm like, oh wow, that's awesome. So I'm just throwing out some questions really. Well, how can the steel fabrication industry or any of our industries benefit from the cloud or whatever, or the big server in the sky, whichever you want to call it? It seems to me that we should be accessing data in the cloud right there to the shop floor worker who's assembling a beam. Why can't he have live data or live alerts or, oh shit, don't fabricate that beam, something changed, right there now, stop. Why does he have copies of drawings still on his desk? And then that copy of drawing is also over there for the quality control guy, and another copy of that same drawing is over there with the project manager. And then one of those copies of those drawings changes. Okay, well that guy gets it, and that guy gets it tomorrow, and that guy gets it the day after, and it causes all kinds of problems. Why can't we have all that data in the cloud in someone's, this isn't rocket science, right? Sensors, RFID. This is pretty well established technology, right? You told me about this morning. And we've established that there are some parameters, perhaps with steel, that RFID isn't the right way. But some kind of sensors that would, one of the important things in steel is we need to know the chemical properties of the steel all the way through its life. Even when it's cut into 3 pieces, you know, one piece comes from a certain heat. That heat has certain chemical properties. Later on, that beam gets other properties, such as a beam mark, such as a globally unique ID, such as holes drilled in it, and other things. And that information needs to be added to it. But how do we build this sensor kind of technology, RFID or whatever it might be? At the moment, we use barcodes. Barcodes get ripped off, or they get pulled off, or they're on the wrong side of the beam, or whatever it might be. How do we take advantage of that in the industry? And by the way, RFID could also be for tracking your people. Is that guy in the right place at the right time? Is that tool over there supposed to be there? Why can't we have smart tools that have RFID tags on them? Say, that tool shouldn't be there. Why is it on? It's not at a workstation. So, drones. And I love this story, and I saw another story on this yesterday. Some startups starting to deliver. I can't remember what it was he was delivering, but you know, the applications for drones are just exploding. Has anybody watched TED videos a lot? Yeah. Did anybody seen the TED video on the guy in Brazil who wants to deliver like medical kits to remote places and what have you? I mean, awesome technology, awesome application of drones that can get to remote places where there's, you know, people need medical assistance. But how can we? Is there any application for drones inside a structural steel fabrication shop? I kind of doubt it, because, I don't know, it just seems a bit... But the point is, drones aren't the point. Drones are not the point at all. The point is, it's an unmanned vehicle. And if you go into any automotive shop, you'll find unmanned vehicles. They deliver materials, they deliver equipment, they deliver accessories at the right place at the right time. So perhaps there's opportunities for unmanned vehicles in a fabrication shop that deliver the bolts, or deliver the weld wire, or deliver whatever it is to the person at the right time when they need it. Because the worst thing you can do in any, well, there's people disagree with me on this is my personal opinion. In my view, you want the person who comes into work, especially in a dangerous environment, to stay in one place, and you want the materials to come to him. As soon as he wanders off, he's in a safety hazard. Because a crane could be moving a piece, or someone could be walking around. So, you know, perhaps there's an opportunity there for unmanned vehicles. Talking of safety, I already mentioned this actually, but tracking people, tracking material, tracking tools, and really tracking that those three don't collide in a kind of bad way is really what this is about. And that all comes back to sensors, right, and processes as much as anything. Smart tools, I mentioned smart tools. There is an initiative about smart tools that especially for the construction site, that allows you to schedule where equipment should be during the process of the job. That seems smart to me. And maybe there's something to deliver that tool to the place at the right time as well. But then the tool will only work when it's at the right place, at the right location, ready to be used in the schedule. Okay? Maybe there's options for smart tools as well. Then we get to augmented reality. I actually love this picture, because I'm sure we've all done it, actually. It's that bit that I like. It's a lie. Augmented reality. It's being used and it's being developed for construction in a number of places. Georgia Tech are certainly on this. But I'm going to sort of touch on this a little bit more, because maybe a lot of the augmented reality comes down to wearable tech as well. So that, you know, you've got a picture guy wearing, you know, alerts here, and I've already talked about this. It's interesting that all of this ties together. But this guy, this is a picture from a Boeing, the Boeing website, where the guy's got his glasses on and he sees what everything is in the plane, just right there in front of him. Well, you know, I'm sure there's an application for that in steel industry where the guy can be wearing a set of safety glasses and he's got a picture of the drawing inside his head that's, by the way, read from the cloud, and he can see where everything's supposed to go, and if he's putting it in the wrong place, and the sensor tells him whether he's got the right beam in front of him or not, and you know, this seems like something that's really doable. And then this is the same thing. This is actually, I think this is in a, I think I took that from a Boeing website as well, but it's the same thing. It's just not a wearable glass. It's just a heads-up display that sits in front of it. So these are just things that are going on in my head as I look around and see technology growing around me. And I talked to Malcolm a lot this morning about laser scanning. And this is the handheld scanner I was talking about. But this is a handheld scan. That's a handheld scan there. Well, we have a situation in a steel fabrication shop that basically we have a model. We know what the thing should look like. We drill it, we cut it, we cope it, we send it through, we assemble it, we put clip angles on the end of it, we put stiffeners, we put plates, we weld it. Well, it seems to me like we should be able to scan that, compare it to the model, and do a quality control check. That doesn't seem very far-fetched to me. It seems perfectly doable. And I've had it confirmed this morning as well. So you know, that technology, how do we bring that? Maybe it's a cost issue, I don't know, but how do we bring that to the structural steel industry and to the timber industry and to other industries? When I say structural steel, I'm really talking about MEP, I'm talking about timber, I'm talking about steel, but obviously I have to come from the steel industry. So that seems to me low-hanging fruit. And then this is, well, we're here, aren't we? So, well, this is a question that I may be out of touch here. Is there a space for some kind of social media that's focused on project teams or construction teams or something like that puts together construction teams or puts together expertise or puts together, I don't know, it's just purely focused on construction. Do you know what I'm trying to say? Instead of, there's nothing like working with a team and having them all in one room. So is there a way that is there an opportunity for some kind of social media to branch out and focus on construction teams or focus on some kind of project team basis? I know that there's various collaboration tools out there, but people have jumped on the idea of Facebook and they share like crazy. Well, is there an opportunity for the construction industry to share like crazy? I mean, I know we've got to ignore contracts in this situation, but you know what I'm trying to say. And then, as I said, all this comes together. I mean, none of those things that I've talked about, and I'm sorry if it's kind of disjointed, I'm trying to think it through at the same time. All these things really tie together. So what I'm really trying to say is, what if this beam that's being fabricated has some kind of sensor on it? This guy's looking at it, okay? As he looks at it, the RFID's sending the information to the cloud's returning the model information through his Google Glass, he's able to check it, the scanner comes along, scans it, checks it's okay, sends it to the cloud, and everybody on Facebook understands that it's done. That doesn't seem far-fetched, right? That seems something like AEC Hackathon could hack together, right? I mean, all the technology's there. And by the way, this doesn't need to be Google Glass. This could just be tablets, or it could be a screen in the shop. That's just probably a little bit out of reach now, but there's no reason that couldn't be an iPad or a Nexus or something like that. So really, that's all I got. We started off here with basic information here. I can talk about the various things that we've got going on in various places if you want to know about them. But I'm just trying to piece together. My job is to look at technology and understand how it might fit in the structural steel industry. I know exactly what's coming to the steel industry, but then I look at the gaps and I see there's opportunities for more stuff to come, and I wonder how we can get there. And maybe the issue is just that it's such a small industry that there's no incentive for people to go there. I don't know, but maybe if we join together across various industries, maybe there's more incentive.